A very good morning to all the folks who are present there for DevOps Canada Day. A very warm welcome to all of you. Today, I'll be talking about the maturity model for DevOps, the far and the near. By far and near means what we are currently probably doing and what we should ideally be doing to reach a state which is adding to the value of DevOps that we have. A quick brief about me. I am Kalpna Gulati. I am a software professional with 22 years of active software development experience. I'm a senior director with an organization named Pitney Bowes. I'm with the India subsidiary of the organization, so I'm with Pitney Bowes India Private Limited. I've been leading development for world-class enterprise applications, including SaaS, API-driven, and microservices-driven applications. I've participated in several technology events across India and across the globe, and it's my privilege and I'm honored to be part of this wonderful event, which is Canada DevOps Day. You can reach out to me even after this if you have questions on the email and the details below. Now, why is it important for us to be here in the first place? And why is it important that I talk to you about what I'm talking, the far and the near of DevOps? If we look at the statistics around cloud computing market share, in 2021, we were around 380 billion market, right? US dollars. And by 2030, this market is expected to be reaching somewhere around 2000 billion, right? So we can very well imagine the state of the cloud computing or the SaaS-based cloud hosted softwares. How much of a cloud inventory and how much of cloud infrastructure would we be using as we move ahead in our development practices? To add on to this wonderful stats is another interesting stats that the cybercrime against all the development environments or the cloud hosted environments, is also expected to reach around 25 trillion by 2027, right? So as we move more towards cloud, the the attack surface that the uh, hackers or the threat elements can have, that also increases manifold, right? And that's the reason when we talk of DevOps in the development practices, we have to be very, very mature in our thinking. So when we talk of DevOps, people generally think of it as development and operations, and that is imbibed in the entire delivery cycle. My recommendation to all here would be instead of calling it as DevOps, we should now be calling it as SecDevOps because of the stats that we just saw that the cybercrime industry is absolutely on a full swing to attack these environments as well as making sure that they're leveraging these environments to have ransomware attacks, malware attacks, and all kinds of attacks that are possible by any such threat vectors. As a result of that, the SecDevOps model should essentially consist of security as a key element in addition to what we earlier used to do around development, operations, and delivery. So in the presentation today, I'll be walking you through about the far and near as to how we should be envisioning in our platforms the security DevOps model. So the agenda for today's presentation would be around what SecDevOps is, which I just discussed, and how is it different from DevSecOps. You know, people generally feel that they are same. There's a slight difference which I would like to call out. Then there is a maturity framework which I would like to address, which is called the GFFP maturity framework. It's called the Govern, Find, Fix, and Prevent Maturity Framework. We'll go through this and dive into the details of this framework. And then we'll see how the GFFP framework helps SecDevOps in the farther and the near times, right? So we'll figure out what best we can do in the immediate future and what best we should be doing as we move ahead in the future. And then obviously at the end of the result, we'll have a maturity model for our SecDevOps practices. So we'll keep our focus on these five, which is primarily around the GFFP framework. Now, whenever you put in security as a retrospect into your DevOps practices, this is exactly what you end up doing, right? And plowing what you have already built is generally a very cumbersome, time consuming, and cost consuming activity. That's why whenever we talk of our DevOps pipelines or DevOps processes or DevOps mode of development or DevOps in the SDLC, we should always take care of security across several uh, phases of the platform engineering that we undertake. We should think about the network level security or the layer 7 security. We should talk about the security and application practices that we should be following during our SDLC. We should be thinking about the security of our deployments in the infrastructure, whether it is cloud or whether it is on premise. And then obviously there should be a continuous cycle of monitoring our security with our DevOps so that we have a complete end to end secure framework to be delivering our platforms. And that's why I say SecDevOps is not equal to DevSecOps. We should not be encouraging up plumbing work into our pipelines when we are hit with security issues. Security should be ideally built into every practice that we do for platform engineering, right? A very efficient framework that allows us to do this is called the GFFP framework. The GFFP framework is based around the govern, find, fix, and prevent theory. What it says is that you have to govern a couple of things, which include your assets, which include your compliances. It could be GDPR, it could be SOC 2, it could be any legal compliances specific to the federal governments, it could be anything. It should also govern the security of the vendors or the third parties that you use. So, for instance, if I'm developing a software which makes use of a third party software or is making use of a third party to deploy my software, I should be making sure that I know what the vendor security is in place. There should be governance around it. And obviously, there should be metrics around each of these governance. When we talk of find, we should be able to find the issues through penetration testing. We should have automated scans through our entire SDLC life cycle. We should have security code reviews, not just normal code reviews that this if loop is taking more compute power or this could have been done with a different method. Not just that. I should also be able to look at security loopholes in the code through the secure code reviews, whether my code is susceptible to an injection attack, whether my code is susceptible to any cross-site scripting attack, right? And then, obviously, if there are any vulnerabilities that have been disclosed, my software and the practices around it, around the entire platform that I have, should be able to disclose that this is the vulnerability that exists. So, there should be a framework in place that tomorrow, if there is a vulnerability like, say, the Log4j that we had a couple of years back, or the color and faker vulnerability that we had for the open source a couple of years back, the if I am ending up using any of these libraries in my system, the moment that vulnerability is flagged, the platform should be such that it gives me an intimation that you have this vulnerability affected library, take care of it. By fixing, we mean that we have to engage with the product, with the platform, and with the teams to ensure that there is the moment there is a fix or something to be remediated, it is done. We have to communicate within our teams. We have to integrate remediation as part of our SDLC processes. If there is a high or a critical vulnerability in the system, the software should not go into production. Something like this. It should be well integrated. And obviously, then there should be a continuous tracking and reporting around this. And then finally, preventing, right? That I should not end up in a situation which requires me to fix. Ideal state, but we should at least aim for it. So there should be findings based on training. So when we talk of training, we mean not just the training of, say, developers or training of the testers. We also mean that people should be trained to find security loopholes in the code. People should be trained to do fuzz testing. People should be trained to do things like, sending random strings or random queries that allow the system to be stress tested based on what security loopholes can exist. There should be a threat model around the entire platform that you design. By threat model, I mean there are certain frameworks which you can use for threat modeling, but at the same time, even the developers should know that what are my endpoints? What is the egress and the ingress? Is it required? Should I be allowing this particular port to be open? All these thought processes should go while developing your platforms and softwares. And obviously, then you should not only confine yourselves to these testing, you should also look at, should I be putting in a WAF in front of it, an application firewall in front of it? Should I be doing some dynamic testings around this? Should there be some security frameworks? There are several frameworks. There's NIST, there's CIS, there is ISO. There's hundreds of such frameworks available. And should I be complying to such configuration standards? And if yes, what advantage do I get? Right? So this is the high level of the GFFP framework, which allows me to govern, which allows me to find, which allows me to fix, and which allows me to prevent. If we follow these four, it is very likely that I'll be in a situation where I can manage anything that comes up because of the dark web or because of the threat vectors that are all around the world and prevent my platforms. Now, going into the details of each of these, there are a couple of segments that we should be covering under each of these. And for each of these segments, I'll walk you through as to what is the general trend, current trend, what is the near time solution, and what is the far time solution. By far solution, I mean something, an idealistic state that we should have to be at least in a reasonable situation to be safe from such threat vectors. So for governance, we'll talk about what we should be doing with image management, what we should be doing with logging, monitoring, and alerting, what we should be doing with patch management, the platform governance, change management, and vendor security. So I'll quickly walk you through around each of these. Now, when I talk of image management, the level one would generally, and going forward for all of these, level one would mean what is happening currently in most of the systems or platforms. Level two is the near time solution, and level three is a good enough solution in the coming future, right? So, for the image management, what happens as of now is application developers, they choose an image and they start their development. Ideally, in the current situation, it should be that the application developments must ensure that all their images are secure from scratch, or if there are vulnerabilities popping up, they are addressed, right? In the near time solution, and I think this is being done in a couple of organizations, we have to ensure that the application developers are given a base image which is already hardened, right? So for instance, if I'm using a Linux machine, I should have the latest version of Linux, all patched, all vulnerabilities addressed, and this base image should then be used by individual application developers to add on their components, add on their application code, and the other framework elements that they want. But the base image should be already hardened. This is the near time. An idealistic approach should be that the application developers are provided hardened OS images and the images that are the base images for a couple of them. For instance, if I want an Nginx based system, so I give them a hardened Nginx image, which makes use of the latest version of Nginx, which makes use of the latest version of the OS that supports and is well patched. If, for instance, somebody wants an RDBMS image, they should have the base image, which is hardened. An application software could be an RDS or any other software that they might want to use for their database management, well hardened, and then they can build over it. And their responsibility is just to ensure that they are all the time adhering to the best base image that is available, right? So that gives a very decent protection as well as is a good SDLC practice for the SecDevOps and for the platform teams, because there is continuous development and we don't want to lag behind on a version which was launched probably 6 months, 8 months, 10 months back. Next one comes in logging and monitoring, right? A very important aspect, logging, monitoring, and alerting. So as of now, in current systems, either the event capture is not existent, not granular, or is not available to the developers or the platform owners. Now, this becomes a challenge because if you do not have the right set of logging and monitoring available, it becomes difficult to understand some key issues that might erupt or some key events like escalation of privileges or anything else that might disrupt the teams later, right? The near time solution is that platform owners should have an awareness of the platform health as well as the individual applications that are running on those platforms. Every microservice that contributes to the platform should ideally be health monitored as well as monitored for any activity that may not be right for the platform. For instance, if I have a platform and somebody spins a very large machine in my account, in my cloud account, I should be alerted. It should be monitored. There are certain, if somebody is trying to escalate the privileges to a root user or to a super admin or an administrative user, I should be aware of that. I should be alerted. And then obviously the third level or the ideal state to be in is that the application owners have full access to their application event information. Any event that is happening which is relevant to the system should be monitored, logged, and there should be an alerting flexibility for their own use when they want to be alerted and when they do not want to be alerted. And this should be ideally in a single platform, obviously with disaster recovery and everything in place, through an enterprise wide logging and monitoring system. The advantage that we get is if there is an enterprise wide logging and monitoring system, every system that you build can leverage the same capabilities. So you don't have to reinvent the wheel again and again. But if it is extremely tied into the vendor, that comes with a risk also. So you have to weigh in your risk, you have to weigh in the disaster management, you have to weigh in your dependency on the vendor, and then come up with a solution that is enterprise wide available with appropriate logging, monitoring, and alerting. Next comes patch management. And trust me, in my 22 years of experience, this has been one of the major and most difficult challenges to address because by the time we start development to the end of development, there are several patches that have come in. Some change the signature, some cause a bigger change, right? So it is not easy. Currently, many teams, what they do is that the patching is manual, right? They go ahead, okay, fine, a new version has come up, I patch my systems. And also, what I've seen with my experience is that it is not enforceable. People do it at their own, will and at their own, time decided, okay, we'll do it after this deployment, we'll do it after the holiday season, we'll do it after the quarter one, quarter four, whatever. A near-term solution should be that the security teams and tools inform the application or there is an automated way of informing through some tools that patches are available and it is the application owner's responsibility to be aware of those patches and implement them. And obviously, based on the fixes in the patch, you have to have a timeline. So if there is a critical fix that has been addressed, fix it in a week. If it's a moderate fix, we give you a month. If it is a low priority fix, take a quarter, right? But this has to be kind of tied into the teams and their security leads to make sure that patching is done at a regular interval and with a regular cadence, and preferably it should be done well in time. An idealistic approach would be an automatic system that does this, right? So it automatically is notified when there is a new security related patch or any critical fix patch. And the platform are able to identify which applications are using which versions, click, 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 and then they are able to have these patches done. No downtime for patching would be required. It would be done automatically on the configured scheduled days, depending on the business requirements of the application or the platform, right? So these are a couple of things that we should keep in mind. And trust me, patch management has been a challenge for most of the organizations. Now, coming back to another major point, which is the platform governance. When we talk of platform governance, it talks about who can make changes to the platform. How is it regulated? How does it flow from the branch to the master, right? Generally, what is happening is changes are conducted ad hoc without transparency and unadvertised to the users of the platform. So, for instance, if I'm using, say, Golang or say Python, I find a new patch, I update it. Did I bother to inform my customers who are using this platform? And by customers, it need not mean the external customers. It could also mean the internal people or the internal teams who are using the same platform as yours, right? That is general practice that happens. And then there is again that plumbing work that goes in, okay, this platform has changed, so now we change our libraries, we change the dependencies, and there's a rework. Level 2 or the near time solution would be that the platform change is conducted through a defined process with manual components required to conduct, but relying on a consensus over the criteria of making the change. Why am I making the change? Okay, fine. This is a major security fix. This is being exploited in the industry. I need to make this change to the platform. Everybody is intimated and that change is made. This will be kind of a manual change, but at least everybody will be well informed. A far-sighted approach or the ideal approach would be that even this change is automated, right? So the moment there is a change, this is a defined process, right? There is a clear criteria. Okay, fine. Five high criticals being addressed in this, or a single CVE which is being addressed in this, which is highly critical. This meets my criteria of an automatic change to the platform. An email goes. Uh, People, if they have concern, they can respond back. Otherwise, this change is automated. Once that change is done, the application developers are informed through the automated process, and the platform governance ensures that nobody is impacted, right? So this is another major thing which is essential for all the platform teams. When we talk of the change management, uh, there's another thing that is important is the entire change management process. Now, by change management process, I mean that there is no version, as of now, many times I've seen there is no change management or version control to the softwares, the documentation, right? The near-term solution is that the application teams, they have to have a version control, but then it may not be a very standard way. Some may have their own process, some may have their other process to change the version. There's no standard process. Every team may be using their own. The idealistic approach would be that version control is a key method of managing the application lifecycle, right? It has well-defined standards, and it is all across. It is same across different teams who are using the platform, right? So and it can also be shared across applications. The entire change management process should be shared. So there is a consistent process at least across the organization. So that if I come from a different team and I see your documents, I know what I'm seeing, right? I don't have to reach out to somebody that what was this change, why was this change, right? And one of the other key things that I've seen over the industry, which I am not sure is being very strictly followed or rigidly followed, is vendor security. We all use cloud vendors, all are always with so many cloud computing applications being hosted, so much SaaS software going online, so many vendors available to choose from. We go, we explore a cloud service, we find that this is good enough, we use it. Very rarely do people go and bother and read about what is the security guideline for this service. Most of these organizations or the companies that offer cloud infrastructure or PaaS services, they are in a shared security model, right? Part of the security they own and part of it is on us. Now, do we really go and care about what is in it for on us? Or do we just simply go and rely that the vendor must be taking care of it? So that is one thing. The other thing is any third party component that I may be using, I also have to ensure are they having their right security practices in place? If their software is being used as part of my SDLC, I am equally at risk if they get compromised, right? As of now, in many organizations, what I've seen is there is no vendor evaluation and the attack surface of the vendors is not known. Teams do a random check sometimes, but it is not a complete tight process around finalizing the vendors. Some of the organizations, even today, they do have separate vendors and there is a security benchmark. So for instance, they have to be SOC 2 compliant. They have to be, following the CIS framework or the NIST framework. But ideally, the vendors should be standardized across the organization with their benchmarks clearly defined. We should have their security footprint. We should know what tools do they use to check their security? What is their remediation process? What is the process of raising an incident in case they are compromised? What is their disaster recovery plan in case they are hit or in case they are down? And how am I impacted? How are my customers impacted? So just going and clicking on a third party service that yes, it helps me, or going to an open source community and seeing yes, this software helps me, downloading it and using it, it does bring a risk to my pipelines and my software and platforms, right? So we have to be very mindful as to what we pick, how we pick, and why we pick, right? So all this was around govern. Next comes the find. By find, we mean how, in case affected, how do we ensure that we have the right processes in place which prevent any of these to impact me, right? And some of these elements are secure coding practices, unit and integration testing, deployment techniques, escalation management and account management, performance and availability management, network management, and obviously backup and the data lifecycle management. And data lifecycle management would mean anything that is important to the organization is managed appropriately. For secure coding practices, there are things called SAST and DAST. So generally in current organizations in level one, I would say that SAST and DAST are being done every quarter for the application and the endpoints. By SAST and DAST, I mean the static application scans and the dynamic application scans. And generally, if there are no high-end or critical vulnerabilities there, they should be good. Level two should be that SAS and DAS scans are run every quarter, and there is also a red team exercise. By red team, it's like ethical hacking done within the organization by a set of ethical hackers that is done regularly. And there should be no high or critical vulnerabilities, and secure development environment guidelines are followed. An ideal situation as we move ahead, it should be that the SAS and DAS scans are done every quarter with no severe and critical vulnerabilities. Red teams are done. Penetration test is also done with a regular cadence. And there are no high or critical vulnerabilities existing in the system. And this should all be automated as part of your pipelines, right? So the moment, so for instance, if your SAST scan runs and there are two critical vulnerabilities detected, the pipeline should break. You should not allow the code to push to the environment. The code developers go, they fix that vulnerability, and then the pipeline succeeds, right? Next comes an important aspect of unit and integration testing. As of now, I do see certain platforms who have a manual unit and integration testing. A near-term solution should be some level of automation for these, and the automation test coverage should at least be close to 60%. And the idealistic approach or the near future approach should be that the automation test coverage should be at least 90 to 100%. And every time there's a check-in, there should be a kind of all the appropriate test cases should be executed to ensure you have not broken anything, right? Then comes the deployment technique. Deployment is manual as of now in many organizations. However, now I've seen many teams are moving towards automatic CI/CD processes. Um, there, there has to be minimal manual steps and shared artifacts through emails or anything to ensure that the deployment is one click. The ideal approach should be the only manual step to deployment are those explicitly designed to meet the application expectations, right? So for instance, if I really want a toggle to be allowing a feature not to go to production, that could be done. That could be a manual change or manual switch. Otherwise, ideally, it should all be automatic. You click and you deploy. And this is one aspect where most of the organizations have made uh, a very good leap. They have taken a very good leap, and most of these I've seen are in level two or level three, right? Then comes the account management. This is very critical, and is generally at times ignored. People may use basic authentication. They may use long live tokens. Should use OAuth based authentication or any such other uh, you know token based authentication, and the token should be as short lived as possible. So currently we have seen that user management may be manual. You raise a request, it goes for approval, or the secrets say or SSH key or anything else is being shared person to person or person to platform, right? Secrets are hard coded either into environment variables or configuration files. All this should not be done ideally. Level one should not exist. User management should be done through automation with a fixed set of users and their privileges. Secrets should be stored or passed through secure methods. Secrets are not even required to be accessed by people in order. Everything that an individual is using or doing should be by their own creds so that you know there is an audit trail. And anything that an application is doing can be done by a non-interactive service account, right? And the ideal approach should be that all secrets should be part of a vault, right? User management should be self-serviced with appropriate security limitations. Least privilege principle should be followed. People who do not require administrative privileges should never be granted those. So this allows the system to be stable. Again, availability and performance management. Ideally, when we launch a software or a platform, we generally don't define any availability. We just launch it and it is an afterthought. However, in the near-time solution, the platform has or it should define an availability expectation that my system would be available for 3 nines, 99.9, or the availability is 4 nines or 5 nines or 99.5 or 95, whatever it is, you have to define it. And in the long-term situation, the platform should be able to manage the availability for the application owners through automation based on application needs, right? The platform should be providing direct insights into the application health as well as the performance. It should be able to move across multiple regions, multiple zones, should be able to react to disaster recovery or if there is any threat activity that they see. Next comes the network management. Now, as of now, what happens if an organization is having, say, 20 platforms, it is likely that each application defines and manages its network structure, inclusive of security assessments on its own. Ideally, uh, or in the near term, we should have the platform govern the overarching network infrastructure supporting the applications. So if there are 10 applications, the underlying architecture or the underlying network deployment may may be same unless there is a separate need for some specific requirements. And ideally, the platform governing the overarching infrastructure, which is supporting similar applications, should be well defined through a governance mechanism. And application owners can make limited changes to their network infrastructure as long as the persons or the key architects who designed this network infrastructure are onboarded, right? And the compliance checks are in place. And then obviously around backup and data management. Manual management of data with little or no tooling is exactly what is happening in a couple of things. But there are many organizations who do take regular backups through automation with little intervention required. Ideal approach should be that the entire data backup should be automatic. In addition, there should also be a data management, identifying and classifying through the entire set of data that we have what is critical or what is company confidential or what is client confidential or what is a PII data. So that level of classification and ensuring that the organization is complying to those should be respected. And this is also being done in most of the organizations, especially around data classification. Next, we'll talk of fix. By fix, we mean that we should be able to communicate and report, integrate the right set of tools, engage with the operations team, and obviously there should be a complete or holistic vulnerability management program that allows the teams to kind of mature their development cycle. As of now, I've seen collated reports of all findings that are either sent manually to the teams or there is no regular cadence whenever the management asks for those teams. This is supplied, right? Whatever has been fixed whatever has been found, that is all kind of shared manually. There may be in the near time solution an automated process for the teams, which allows the teams to report it to the management. Ideal state should be the pipelines have automated all the reports being sent. There is a loop back on closing these items and a gradual decline in the number of vulnerabilities that we see. A trend analysis report or a single dashboard which the teams can go and see where they lie and what the trend has been. So a clear mode of communication. As I mentioned earlier, ideally all these scans should be part of our pipelines. I've seen many teams doing this now. All scans are automated and reports are sent in an automated manner in several platforms that I've been a part of and I've seen in the organizations. One thing that we generally miss is the application teams integrating with the security operations control team, right? So generally, for instance, if somebody spins a new machine in my AWS environment, do I get an alert or is the SOC team being notified? Generally, no alerts have been set up when there is an application level threat. Some teams in the near time, we have seen that some teams do that for certain events. So, for instance, if there is an escalation of privilege, teams may have had it. Ideally, there should be alerts in collaboration set up with SOC to ensure that the right set of alerts and alarms are in place. And if there is any such event, the teams are notified. And obviously, then we should have a complete vulnerability management program which identifies what are the vulnerabilities, which identifies how many of them exist, what is the trend, right? Generally, what I see is the vulnerabilities are known, but there is no common cadence or a process to track and fix them. People know I have 2000 vulnerabilities. When will I fix them? I don't know. How will I fix them? I don't know. Ideally, there should be a complete process that identifies these kinds of vulnerabilities fix in 7 days, these kind of vulnerabilities fix in month, and taking that forward, right? So having a good vulnerability management program is another key to have a stable platform and a stable pipeline for the delivery of your platforms. Now, best way would be that nothing like this happens, right? So how we prevent this? And again, that goes up with a couple of things that we need to follow. Security trainings, threat modeling activities, architecture reviews, and certain tools like RASP and WAF, which enable me and my teams to be safe. Talking of security trainings, most of the teams now actually do security trainings. Um, Level one would be that no security trainings are being organized in the organization and people are randomly doing or not doing any training. Level two could be that basic security trainings are being organized in pockets or in a few teams, but no organization wide initiative to ensure that everybody who's in the organization or who's joining up fresh in the organization is being notified of this. Level three or an ideal state should be a security training should be given due importance, and anybody who is part of the organization or who's joining the organization is going through these trainings. Threat modeling, as I mentioned earlier, also there should be a regular cadence. Few projects which are very, very critical should go through threat modeling, and the ones that that may not be that critical may skip threat modeling. But an ideal approach would be that threat analysis is done for all products and platforms, following frameworks like Stride or MITRE, and managing the vulnerabilities that come out of it. And then obviously a complete architecture review of whatever is being developed from a security perspective, from a availability perspective, from all the non-functional requirements that we think of. What is the ingress? Do we really need that much of an ingress? What is this network open to, right? What is the attack surface? How can I minimize the attack surface? All this should be kept in mind, and ideally, there should be a dedicated architecture review board, and all projects and platforms should be going through this ARB, and it should be fixed and tracked. And then obviously, there are certain tools which we should follow, and we should make sure that at least all the internet-facing endpoints have a WAF in front of them. So as we move ahead, the complete maturity model for the govern, find, fix, and prevent would have all these well colored depending on which stage of the maturity model you are. So if you see the inner circle, that's the level one, the middle circle is level two, and the outer circle is level three. So depending on which stage you are in, level one, level two, or level three, you can have a complete maturity model defined for your platform on these three concentric circles. And that ideal state would be when all the segments of the circle or these small blocks in the circle that you see, they are all colored, right? That is an ideal state that we want to achieve. We may reach there slowly, but eventually we would, right? And as I say, right, somebody said really smartly that one who's willing to attain nirvana, in our case, like DevOps nirvana, has to understand four noble truths. These noble truths are understanding of the vulnerability and the risk that we call suffering, the threat that it causes, which we call the cause of suffering, the finding and fixing of these sufferings, which we call the relief for suffering, and the governance and prevention, which is a way to end the suffering, are the four keys to attain the DevOps nirvana. Thank you all for being here, and it was a pleasure having a talk with this. I know we can't ask questions right now, but in case you have follow-up questions, feel free to drop a link or an email. Thank you. Have a good day.